And I hope you can see my presentation. So maybe one of you can give a quick feedback.
Yes.
All right. So one request to all the teachers is that feel free to unmute yourselves whenever you like, and you can ask me questions in between. And if you are comfortable, you can switch your videos on and we can interact. So we want this session to be as interactive as possible because we want to plan a hands-on event, right? So to plan a hands-on event, there needs to be an interaction. Without an interaction, there cannot be planning. So to plan an event, there needs to be a one-to-one communication. So those of who are in the Zoom meeting can easily interact with me directly. Those of who are on the YouTube, I'm sure that we will get the questions in the chat box, and I will definitely try to answer them as much as I can at the end of the talk. So I come from an institute called Ayuka, which is the Inter-University Center for Astronomy and Astrophysics. And I'm also going to tell a little bit about our institute and what all programs do we do. So Ayuka is a research institute. It is the Inter-University Center for Astronomy and Astrophysics. And what we do is we aim to promote the nucleation and the growth of active groups in astronomy and astrophysics. So the word nucleation means as a starting point or a beginning of a process. So often in the cases of stars and galaxies, the smallest building blocks of these stars and galaxies are formed first, and this process is known as nucleation. So it is the very beginning of the coalition or very beginning of the formation process. And Ayuka aims to provide its expertise and resources for that very thing. Apart from that, one of its visionary mandates and one of the unique mandates is to inculcate science interest in the students and inform the public and also promote astronomy. So there are very few institutes in India who have this mandate to carry out science outreach outreach to the public alongside research. And we are very happy to be a part of this particular section of Ayuka, where we get to interact with the public, we get to talk with people, we get to interact with students and teachers, and that's very exciting for us. So apart from that, Ayuka hosts these following programs. So Ayuka has what is known as a SciPop program, which is Scientific Public Outreach Program. And along with that, we had the pleasure of working with Professor Arvind Gupta and Padma Shri Arvind Gupta. And he was very active during his tenure at Ayuka, and he has created thousands and thousands of science toys and similar educational resources for students and teachers. And using those resources, you can very, very effectively learn and most importantly, enjoy learning about science. And one small part of science is astronomy. And today, I particularly am going to focus on how we can plan different activities and events related to astronomy. We also have what is known as Astronomy Center for Educators. And this is essentially a center where we create resource materials for teachers and educators. And this particular session could be a primer for the entire workflow of this particular section of Ayuka called ACE. Then Ayuka is also a member of the mega projects like TMT, LIGO India, and AstroSat, and so many more. There is Square Kilometer Array as well. And I'm sure you must have at least heard about these names, if not know this entire project. So AstroSat is a multi-wavelength satellite, India's only and first multi-wavelength satellite, which is already there in the space. And it is providing us wonderful data through its multiple instruments in X-rays, ultraviolet, as well as infrared. So it is very exciting to get a chance to work with people from these projects. And Ayuka is full of people who are working on many interdisciplinary projects in astronomy and science. So we also have partnered with IAU, which is the International Astronomical Union, and they have these multiple programs called Office for Astronomy Development and Office for Astronomy Outreach. And the National Outreach Coordinator of India is also a part of Ayuka, which is Samir Durde. So he will be speaking in this series at some point later. And then we have outreach with associates. So one of our associates will be giving a talk tomorrow. Her name is Dr. Priya Hassan. And we are very happy to have many associates spread all across India and who are acting as nodal points between the public as well as Ayuka. So speaking of the event planning, so before we talk about event planning, let us see what all events do we plan and do we do. So our forte is particularly into primary concepts. So first is the school level science teaching and outreach, or it is called as the school outreach. And another one is called as the astronomy outreach for common public as well as amateur astronomers. So why amateur astronomers? Because astronomy is slightly, the cliche field, and not all people may be interested in astronomy. But if you organize some good public events, I'm sure people do get attracted to astronomy, and it is indeed a very exciting field. For school level and school outreach, we organize workshops related to science toys. And when we say science toys, we don't just limit to science. We also include subjects like mathematics, physics, biology, chemistry, almost all of the subjects which are there in the school. Apart from that, we organize live workshops, which are around 2 every week, and almost 50 to 100 kids visit Ayuka. So this is this is during the time when there was no pandemic. Nowadays, all of these programs and sessions are going on online. So during this session, during our session today, I will address both methodologies where you can plan an offline as well as an online event. Then we also organize teacher trainings similar to this very session. And these teacher trainings are actually dedicated for 2 or 3 days. And teachers from different parts of India come visit us. They stay in Ayuka. We also organize a trip to our observatory. Ayuka has a 2-meter telescope facility. And along with all these visits and everything, there are 2 full-day packed sessions, one after another, full of activities and full of fun. So teachers are we give our inputs to teachers how they can effectively, inculcate or effectively teach in classrooms. One of the very interesting sessions happened yesterday on NLP, which is neuro-linguistic programming. Another important part, or one of the important part of NLP is kinesthetics, and science toys and science toys based outreach is basically a very important part of this kinesthetic teaching methodology. And Ayuka has its forte, Ayuka has its expertise because of the foundations laid by Professor Arvind Gupta. And we are quite honored to continue this with the help of our teammates. We also emphasize on rural areas and school level programs, particularly focusing on astronomy. We have summer school programs where select few students who are selected or filtered, you can say, based on their interest. And how is that interest identified is we conduct various types of competitions. So there are quiz competitions, there are essay and drawing competitions, and whoever are the interested kids are then invited to come visit Ayuka. Then we guide them and complete a few projects, and then they are trained to present their projects in front of the faculty. So this is a very good learning experience. It also inculcates interest in astronomy, and it also develops their own interpersonal skills. And Ayuka also has provisions for school visits, schools to visit Ayuka, and we often organize different dedicated programs during these visits. And we also have a program on National Science Day where we have more than 10 to 15,000 visitors visiting Ayuka and learning about whatever research goes on here and whatever work Ayuka is doing or wherever Ayuka is involved in. And apart from that, the public lectures and campus visits are there. So all events were live on YouTube much before pandemic. So it was around, we had around 6,661 subscribers. Now there are almost 2,000-3,000 more than this number. And we had around 3 lakh plus views in 2020. Now it has increased furthermore. And it is only going to increase because of the pandemic, everything is online. For example, this very session is online. And we would have been very, very happy to come and talk to you in person, or have you come to us and talk to you directly. But here we are. Some more highlights are that we also have some dedicated resource materials related to science and space toys. We have some mobile planetaria. We have large sky, public sky watches. We have India's oldest and one of the best telescope making programs here with an experience of more than 20 years. And we are already running an online telescope making series nowadays. So you can also learn more about that during the later course of this session. And we have created these packages, about which I will also talk in this session. So there are moon activity packages as well as sun activity packages. And these packages are going to be very vital in organizing some hands-on activities as well as events whenever we plan for the school students. So these are some of the collaborations that Ayuka has with various institutes and organizations. So moving further, what will we learn in today's session? So today's session will mainly talk about how to plan the event. What all things do we need to consider when planning an event? And this can be any event. So I am going to take examples of the events that we plan and we do. So it becomes much more sensible to give some examples, give some photos for showing how exactly we run these events and how we follow through. Then to revise yesterday's session. So it is a very, very good idea, and it is very important that we use good NLP techniques to inculcate effective learning methodologies. So during and after the event should be a good learning experience for both teachers and students. And if you are using good NLP techniques, it is only going to help you more. What kind of events can be planned is something that we will also talk. And what tools are there to find out about the astronomy events and activities, and which websites and applications are effective to plan these events well. So we will also see them. So these are some of the names. So I'm also going to show the websites firsthand. So I'm going to move out of this presentation. I will go to that website and I will show you how exactly do we approach when we want to plan some astronomical event. So whenever you want to plan an event, you need a very interesting event or an idea. So there need not always be an astronomical event. You could have a good idea and you can build an event around it. And same is the case with the activity. So the next session that we will be having will address something like this. So we will have an idea or a concept, and we will be building an activity and an event around it. So it is very, very important to have a unique idea and to have the idea as clear as possible to plan an effective event. So next part is you should have the right kind of resources, and you should be able to delegate your work to run your event smoothly. So teamwork is very essential and very important when you are planning an event for school students. So if you are a school teacher, I'm sure you must be having a good experience of dealing with a large number of students from different backgrounds. And when you are dealing with such a large number of students with different backgrounds, it becomes vital to delegate different tasks to them. And based on the students' abilities and their interests, if you give them some interesting tasks, like for example, students who are good at art and craft can create posters and publicity graphics for your event. Students who are good at talking and who are good at presentation can probably anchor the event. The students who are good at designing something can do good publicity of the event, and so on and so forth. And it is very, very important to identify the right kind of resources, which are the human resources. Then there is the technology. So if the event is going to happen online, you need all the appropriate logistics and everything necessary for running your event smoothly. Then you need to know your target audience. And depending upon the target audience, it is very, very crucial that you choose the abstraction level of your event and information that is going to be presented accordingly. And then comes the another part, which is the follow-up. So once you run the event, then comes the follow-up part. So that is equally important for replicating the event or generating a good report of the event and understanding how effective was whatever event or activity that you created was. So this is crucial. So apart from these four things, we will see how we moved, or how we particularly at Ayuka address this event planning. So first thing is that we do a little bit of research about the event that we plan to do. And one of the important finding that we would like to share is that this paragraph is taken from a paper by Rousseau. This is the link of that paper. And it says that we find astronomers develop an interest in astronomy between the ages of 4 to 6. But that decision to undertake a career in astronomy comes often late. But the basic interest in looking or understanding more about astronomy or stars or planets comes at a very, very young age. And if you are able to, identify and channelize, catch these kids at such a young age and are able to retain that interest in them, then the chances are that they will be very, very good astronomers, and they will thoroughly enjoy their career forever, actually. And it is very important to identify these students. We are speaking in terms of astronomy because we particularly think and are interested in doing more programs about astronomy, because that's what our expertise lies in. But you can replace the word astronomy with anything you like, and it will hold true for all the fields. So the idea is to find the common interest of all the kids and all the target audience that you have, and then you should plan an event around it. So these are some of the numbers that we would like to share. So this was during the non-COVID era. So this was before 2019, and you can see all of these programs are public programs. So the photo number 3 over here is the teachers training workshop. So you can see the teachers are involved in a lot of fun activities. They are making science toys, and then they are also learning how they can teach some certain scientific concepts using those toys. Going further, we should always try to incorporate as much pictures, as much graphics and media in our events, as well as teaching methodologies as much as we can, because a picture will explain or speak much louder than maybe a paragraph. So if you give a definition of, let's say, a particular physical concept, and you show a video, the chances are that students will appreciate the video much earlier, and they will understand it more effectively. So let's take this example. For example, there are these girl students over here, and this girl over here is holding 2 water bottles. And what you see is the transfer of bottle, like water from the upper bottle to the lower bottle. And then the water level matches. So you could either demonstrate this, or you could write a small paragraph about it, but the demonstration will be far more effective. So it is important to identify these important tidbits which you can incorporate in your events and do them. So post 2020, or we can call it a pandemic era, the important tools of our trade whenever we want to run any event were the following. So right now, one of these is already being used over here, which is Zoom. And similar to Zoom, there are so many more teleconferencing softwares. And then there is this mixing software called as the Open Broadcaster software or OBS Studio. I've given this software because it is free, and it is also available on all platforms. Then there are some video editors that you can use for editing videos. So Shortcut is one such free editor. Then you can also webcast your programs for free viewing on YouTube. And that is also what we are doing today. So as you can see, post-pandemic era-based events are now moving online. And we need to be, self-sufficient in handling and executing those events effectively. And for that, we need to be comfortable in using all these tools. And these are some of the free and best tools available in the market. So whenever all these programs that I showed you before the pandemic were all offline, and it was a actually important challenge to move all of these programs digitally, and it required a lot of patience, it required a lot of training, and the programs did not always execute the way we wanted them to be, and it may not have been as effective as we could have run the programs offline. But long story short, the world is changing now. Everything is going digital, everything is going online, and we need to adapt with it. And these are some of the examples of the events that we arranged. So these similar events can be arranged in schools as well. So one example of the event can be a moon challenge. So what is a moon challenge is, you all know that moon shows different phases. And the reason moon shows phases is because the moon revolves around the Earth. Now, the moon requires 27 days to complete one revolution around the Earth, right? And during these 27 days, the moon shows different phases depending upon the orientation. So let's say if light coming from front of me is the sun, and if my hand is the moon. So if the light is falling directly onto the moon and Earth is on the opposite side, then I'm going to see the full moon. If the sun and the moon are very close together, I'm going to see no moon or a new moon. And as the moon goes away from the sun, the illumination of the moon is either going to increase more and more or decrease more and more. So this is how we experience phases. Now, the activity can be as simple as that. Students just need to go and observe the moon every day. So once they observe the moon, even with the naked eyes, they will be able to spot the different phases of the moon. They will also learn that if they are observing the moon at a certain time, on the next day, the moon will have shifted towards the east. Okay. So within a matter of 2 days, the students will immediately learn that every day the moon is rising towards the east, which means that the moon is revolving around the Earth from west to east. Okay. And every day, if somebody observes and notes down the timings, then they will be able to tell that every day the moon is rising 50 minutes later than the previous day. Okay. And these are some of the simplest activities, and doing these simple observations will help them learn about the motion of the moon. They will learn about the phases of the moon. And if at all you have access to a telescope, and if the students are allowed to see through that telescope, they will discover that every day newer and newer craters are getting visible as the phase of the moon keeps on changing, right? So if you look at this photo over here, so this phase was around the second or third day after the new moon, and you can see some beautiful features on the surface of the moon, right? And if you have a telescope, what you can ask the students to do is they can draw a circle and they can mark the positions of the craters that they are seeing on the moon. And then there are very, very good quality lunar maps available on the internet. So they can find out which crater were they able to observe and they can mark it. So this can be a very good exercise, and this will help them learn about the lunar craters and lunar features. Now, one very good question could be why? So the most important thing is to develop curiosity and to develop the understanding. So if you observe the moon through the telescope, you will exactly understand what I'm trying to tell you, because looking at moon is very exciting and it is beautiful. And when you observe the moon for many days, it is likely that you will be able to discover even new craters. So Earth has a thick layer of atmosphere around it, right? So many meteors or many rocks or dust particles which enter the Earth into its atmosphere burn away. In case of moon, there is no atmosphere. So any rock which is trying to hit the moon directly impacts on the moon's surface and a new crater is formed. So if you are an astronomer and if you are looking at the moon, chances are that you will be able to discover a new crater. And that is very exciting. So I can tell you an example of few days ago when some amateur astronomers in Brazil were looking at Jupiter through a smaller telescope, right? And what they observed was very exciting. Think about this. You are looking at the planet Jupiter and a rock starts to enter into the Jupiter's atmosphere and burns. And then there is a bright glow on the surface of the planet. And you are able to not only see it, but also get time to photograph it. Now, that is extremely exciting. And what these astronomers have done, these amateur astronomers or hobby astronomers have done, is they have found an asteroid being entering into the Jupiter's atmosphere and burning. So this is a discovery. This is a brand new discovery, and this is a very, very important observation. And this was possible just because they were looking at Jupiter for fun. And this is the reason why you can ask students to do this activity. And it is always exciting to look at the moon and all the astronomical objects. And it is a very good learning experience. And I personally would definitely recommend doing it. I still enjoy doing it. After my office hours, I often go to the terrace and I set up my telescope. And I still look at the moon, I still look at all the planets. And it is really fun. Then there can be some activities or events which can be planned for creative students. So not all students will be good at putting instruments together, setting up a telescope, observing things, right? Some students are very creative, and they can be good at some literature. So some of them could be good at writing stories, some of them could be good at reciting poems, some of them could be good at drawing some good paintings. So you can arrange some events related to science fiction stories, science fiction poems, drawing, quiz, and all these things. So it invokes their curiosity, and it makes them think about a particular topic for a certain amount of time. And even more important is to compose their thoughts together and write about it. Okay, if not write, at least recite about it. So this is a very, very good exercise for school level students, and this can be a very good event. So this is just an example. SciFi Enterprise was one of the events that we did. But what you can do is you can further expand this idea, and you can add so many more things in it. So you can incorporate, or you can combine art and science, and some dedicated events related to that can be planned. Then there are some specific events around the year which happen and which should not be missed. Okay. So now some of the events are like annular solar eclipses are there, total solar eclipses are there, lunar eclipses are there. And this happen every year. So maybe not for your particular location, but they happen someplace or the other in the country. And unfortunately, in spite of these events being very beautiful and magnificent, there are a lot of misconceptions which come along with these events, right? And we as science students and science teachers is very, very, for us, it is very, very important to, stop these misconceptions and inculcate the importance of scientific thinking and scientific thought. So before I move further, I would quickly like to tell you, so this particular event, which is the SciFi Enterprise, won the first prize by the International Astronomical Union for one of the best event ideas. So why we started this event was to increase the community participation, and we wanted everybody to participate and think about and write about astronomy and spend a little bit of time to wonder about what all happens in science. It could be fiction, it could be about aliens, it could be about space travel, it could be about having your school in space, which is not very far. So right now we already have space tourism, which has already started, right? So maybe 10 years from now, we will get an invite from SSERD like this, and that session will be somewhere in space. We never know. So we really are excited about something like this happening. And we really are looking forward to it. But events like this, which incorporate the creativity as well as science, are very, very important, because it brings out the creativity as well as the the importance of finding the answers through scientific thought. Then there are these specific events like annular solar eclipse or zero shadow day. Zero shadow day is yet another interesting event where you can no, you cannot see your shadow at the exact local noon for your particular location. Unfortunately, this event is possible only for the people living in the tropical regions. So the people living in between 23.5 degrees north and 23.5 degrees south latitudes. Okay, so that is why it is important to also learn about these events and teach the kids about them. So about these specific events, we are going to see a website and some tools where we will talk more about this. I'm going to show you many websites as well as applications where you can find out well in advance, right before the school starts, that when and where will these events be happening, and is it possible for you and your students to view those events and arrange a particular event along that astronomical event. Then there are some interesting activities or series that you can start. So this is something that we had started last year, and this will also be happening starting today. So on 16th, there will be International Observe the Moon Night. And on 16th of October every year, there is this IO event, which is International Observe the Moon Night. So it is just an excuse to go out and look at the moon. And it, basically celebrates the lunar landing. And why we encourage people to look at the moon is that there are so many different things that we can learn about the moon, and we are planning to go back to the moon again, right? So it is very important that we understand a lot about it before we go and stay there. So you can see some of these posters or series of posters on our channel. So then the activity can be as simple as finding an astronomy word and finding its meaning. Okay, and when you find the meaning, it is also a good exercise to find a equivalent name in your local languages. So let's say albedo is called a Paravartan Kshamata in Hindi, okay, or Marathi as well. But a similar name in your own regional language could be found, and that is a very good exercise. So if you write about this particular term in maybe a local language essay, you will be able to make the correct usage of that term. And this can be a very good exercise or an activity for school level students, making such digital posters and spreading them in the networks. Then there are some special events that you can plan. So there are some unique visitors from our solar system that we can often see. Those are known as comets. So if there is a bright comet visible, one should definitely go and see it, because the good visibility, bright comets are really rare to spot. And if there is ever one, there should definitely be an event planned along with it. So to see a comet, you often need a telescope, because comets are very faint. But the comets are also easy to spot with the help of these newly developed applications as well as sky maps. So we are also going to talk about those. So these are some examples of the events that we had planned for amateur astronomy groups and amateur astronomers who already have an interest in astronomy, and these events are to further that interest. Then these are some school outreach events. So one very good event series was called Toy Story with Science. So this was conducted last year, where we had selected a scientist, okay, and then Shivani had found out some stories related to that scientist, and after the story there was some scientific concept taken and a science toy was made, and through that science toy that concept would be explained. So all in all the session would be, there would be a short story with some animations in it. Then after that short story there will be a science toy, and then there will be a demonstration making the science toy. After that there will be a demonstration of the science toy. So there is also a series on basic measuring instruments. So the ideas and number of events are countless, and any number of events or any kind of an event can be planned at a school level. And actually we are excited to hear your ideas. What can you think after this session? So we already are giving you some ideas of and telling you already what we do. So we are excited to learn about what you can think can be done. And we will also be discussing more about that. So all the people in the meeting are strictly keeping their mics and videos off. But I would encourage you to not do that and try to interact as much as you can. The thing is that we are doing a session on event planning, and we cannot plan if you don't interact, is what. So if you are shy of keeping your video and microphones on, you can talk and you can discuss your ideas in the chat. So the meeting will be allowing you to send messages in the chat as well. So then there are some dedicated teacher programs, and these are important. So many a times teachers, although are very excited to teach, do not know the existing resources which are already there, right? So there are some excellent resources designed by the International Astronomical Union. So right now I'm talking about astronomy. So the IAU has compiled excellent resources on astronomy. Then Ayuka has curated some of the excellent resources on science toys on a website called arvindguptatoys.com. So don't worry, we will put all these links and whatever resources that we want you to look at in the chat window as well. And as well as we will be we will request SSERD team to put these links in the video description. Okay, so that will be easiest for you to find. Once you go to YouTube on the SSERD page and reach there, you will easily be able to find these links in the description later. But let's talk about these programs first. So the teacher training workshops can make use of Android applications, which are or iOS applications, which are very, very easily accessible to almost anybody. Everybody nowadays has a phone, right? So I think almost 80 to 90% of you must be using the phone right now. So nevertheless, these phones can be used very, very effectively for teaching. So there are some excellent mobile applications that you can use while teaching certain concepts, because mobiles come with a lot of sensors. So light and sound related applications can be effectively taught using the mobile speaker, mobile microphone. Then there is also a light dependent sensor, also the light intensity sensor. So there are some beautiful physics related apps on the mobile phone as well. And I'm also going to show or talk about them. So I understand that it is almost half time has been crossed. I have, I think, 20 more minutes. So in another 10 minutes, we will wrap this presentation and we will look at all the resources that I have been talking about for so long, right? So this is an excellent tool. This is an open source and free application, and you can download it from the mobile store, or which is the Google Play Store. It is also available for free use on any desktop. It can be Linux, Windows, Mac, any operating system you have. This is an excellent tool, and we need to use this tool a lot as astronomers to plan different events and to know when what event will be occurring, right? So this is a very beautiful free and open source tool. The name Stellarium is basically stellar planetarium. So it will simulate planetarium-like conditions on your computer screen or mobile screen. So we will also see a demo of this app quickly. Then one more very effective method to plan and organize events is role play. Okay, so often when you teach concepts related to science and astronomy, for example, you want to teach about Kepler's law. So what Kepler's law teaches you is how objects behave in space, right? So if there are two objects and one object is rotating around the other object, the object will always rotate in an elliptical orbit. Okay, so even if the orbit is circular, it is still an ellipse, but a special case of an ellipse, right? So any two bodies rotating around each other in space will rotate in an elliptical orbit, right? So this can be very nicely demonstrated with the help of 3 students, right? So in case of an ellipse, there are 2 vertices or 2 centers, and one object is rotating. So on one focus, you can ask one student to stand, and you can ask another student to move around. So whenever the 2 students start coming closer to each other, the student will appear to move faster. And as the student goes further, the student which is rotating will appear to move slower. So this can be very effectively demonstrated with the help of role play. This was one example. There are so many more examples where you can demonstrate how you can only see one face of the moon when moon is revolving around the earth. Why? Because the rotation of the earth and the revolution of the moon is at the same speed. So what that means is the moon is tidally locked to earth. That is why when the moon is revolving around the earth, it is simultaneously rotating at the same angle. Hence, you can only see one face of the moon and you cannot see the other side of the moon from the earth. And this can be very well demonstrated with the help of two students. So one student becomes the earth, another student becomes the moon. And when the moon, the student which is the moon, moves a little bit along a orbit or along a circle, you also ask that student to rotate with the same angle, right? And when the student continues to do that, at the end of the rotation, he has completed a 360-degree rotation as well as completed a revolution around the other student, which is the earth. Okay. And this is very effective in demonstrating certain concepts and certain things that happen in our day-to-day lives. So role play is a very, very important and very effective tool for organizing different activities and events. And it will give you a very good, it will give a very good experience to students for understanding the concepts. So once you ask a student to rotate like a moon, he's never going to forget that, right? So at least for the next 10 years, he's going to remember that, yes, I was the moon and I was rotating and revolving at the same rate. So that is why I always kept facing towards the earth. And that is something which is very interesting. So we would like some suggestions from you. So these are some of the ideas that you can explore. So there are these different tools available almost in every city. You can make use of radio. The All India Radio and FM channels are always eager to bring in interesting people to speak to. So if you are able to collaborate with them, you can reach a lot many people, and you can tell them about your event, and you can ask them to do or run your particular idea. Then there can be bring your own binoculars, or if anybody has a telescope, you can ask students to come together and enjoy watching whatever objects are there in the sky. Then telescope making is yet another event. Making it in a socially distanced method is slightly tough, but it is not impossible. And we are already executing this series of telescope making on the Ayuka SciPop channel. Perhaps you can visit there later. And basically, being in touch and being aware of all the existing resources which are out there and making use of those resources will only add quality to your work. And the more and more resources that you use, the more and more resources that you understand and share will increase the reach as well as the quality of your resource material and whatever event that you're planning. So these are some of the organizations which create excellent resources and make them available on their websites. So you should definitely check these out. And last but not the least, we need to have a good network. So if you are based in a particular school, it is a very good idea to set up a network with similar teachers like yourselves. So if you are a math teacher, talk with other math teachers. See how they inculcate good teaching practices in their school. See if you can incorporate those in your school, and see if you can design something that will be that one will be able to replicate. And that is something that is very essential. Then you can also collaborate with good scientists and experts in a field, and you can set up short training sessions. So interacting with a scientist or a celebrity or some expert often increases morale of the students as well. And not just students, but the teachers as well. So getting a chance to talk with the experts is often very exciting and often very inspiring. So this is yet another thing that can be incorporated in the event. So if you have one full event, it is a very, very good idea to involve experts and ask them to talk or ask them to share their experiences. And these experiences are nothing but inspiring. then there should be a common, well-designed set of ideas, materials, which should be open. So whenever you have very good and effective, event or an idea, it is always a good idea to make it open, so that anybody can make good use of that and help their students as well as teachers. So good idea to increase the friendly competition between the students as well as the communicators is to organize different kinds of contests, and these contests often need some incentive, right? So because of that, many people get attracted to this particular event, and with the help of this publicity, you can push your other events and good ideas that you would like to execute with the help of these people. And then all these events have to be well planned. They need to be timely announced, and most important is that it should be well researched, and the follow up of the event should be also well done, so that whenever that event is complete, you should get a solid idea that how exactly was your event executed, what all was the output, what was the expected output, what was the received output, and how can that event be further improved if one has to do it again. So these are some of the important suggestions or takeaway points that I would like to share. So these are our contact details. So if you want to write to us, you can write to us at scipop@gmail.com. This is our phone number. This is our website. And on Facebook, YouTube, as well as Twitter, our social media handles or channels are known as Ayuka SciPop. So this is how you can find whatever resources we generate, whatever events, as well as informations that we give out. So if you follow these pages and channels, you can stay in touch with us. So although this presentation is over, I would quickly like to show you some resources in another 5 minutes. I understand that I have time till 6 o'clock and it's 5:50 now. So we have enough time to see the different tools that I have been talking about for so very long. So I'm going to stop my screen sharing for a moment. Let's quickly go back to the browser. Very well. So whenever we are planning an event, it is very, very important to understand where and when is that event going to happen. And timeanddate.com is an excellent website. So I'm not doing an advertisement of these websites or resources. I'm just sharing them because they are very good at coagulating all the information in one place. Right? Timeanddate.com is an excellent website. It gives you some good tools, one of which is called a time zone converter. So for an event, let's say there is a solar eclipse in USA, right? And the timing of the solar eclipse is given in, let's say, UTC or Universal Coordinated Time. So what you can do with this time converter is, let's say if the eclipse is happening, for example, in Singapore. So we can add Singapore over here. We can add, right now I'm talking from Pune in India. I will add Pune over here. Maybe I can add another city. Somebody from the participants might be joining from, let's say, Bangalore. Right. So now you see that Pune and Bangalore are in the same time zone. So you can include either of those. And then what you can do is, if you know the timing of the event at certain place, let's say the solar eclipse in Singapore is going to happen at 2 p.m. So you can set the time over here and you can immediately get the equivalent timing for India or for whatever location you have. So this is one very important, very good tool which you can use for conversion, time zone conversion. And while using this tool, you automatically learn what is the time zone of Singapore, what is the time zone of Pune. And while using this tool, or while asking the students to use this tool, you can also ask them to read more about whatever is written here. So you can ask them what UTC is, which is the universal coordinated time. You can ask them what SGT is. You can ask them what IST is, so on. And this can be very good learning experience. Another thing is that this website also includes these different menus. And one of the menus is Sun and Moon. So this menu tells you all about the events related to the sun, moon, and astronomy. Okay. So if you go to the night sky, you will get whatever planets will be visible tonight. All right. And you can see there are these markers over here. So at sunset, there will be following objects that will be visible. The objects which are not visible is clearly mentioned over. Then maybe at civil twilight end, following objects will be visible. This is at moonset. So at moonset, following planets will be visible. You can close this menu. And this is also providing you a sky map. So you can plan, or you can know where which objects will be visible. So if you drag your cursor on some object, you can tell which object is which. So this is planet Jupiter. So today, after my session, if you go outside and if you look in the sky, you will see Jupiter at the southeast position. So you will see a very bright star. It will be very, very bright object. It is not actually a star. It will be the planet Jupiter. And just below that, there will be another planet, which is planet Saturn. So if after this session, if you go outside and look at the southeast, you will see two very bright objects just after sunset. And those will be the two planets. If you look exactly at west during sunset, you will see a very, very bright object. Okay, let's let the sun go down a little bit. And that bright object will be planet Venus. So let's say our session will end at 6:30, 6:45. If you go outside, maybe at 6:45, you will immediately start, the Venus will immediately be visible at the western horizon, and it will be in the sky for a very long time. And if you put Venus in your binoculars, or if you use a telescope to look Venus, you will see something very exciting. You will not see a full Venus. You will see a half phase of the Venus. So similar to the phases of the moon, there are also phases seen for the inner planets. So Mercury and Venus also show different phases. And today, if you see the Venus through your telescope or a binocular, you will see a half phase of the Venus. Okay, that is something that you can check after the session. And this is how you can use this website called timeanddate.com to see what all objects are there in the sky. This is how you will see today's moon. So today's moon will be visible right after sunset. It will already be overhead, and so on. So this is one very good website. It has so many more menus. And in this menu for eclipses, you can get a list of all the eclipses that is going to happen. And if you look at this map, you can tell where exactly will these eclipses be visible. And if your school or your location is in that particular region, you can easily plan an eclipse event along with your students. So this is one website. This is another website called earthsky.org. This website also gives you a list of all the events that you can plan, you can see. So there are these astronomy essentials also. So there are some very good articles that this website has curated on how to plan an event for a particular astronomy event, how to observe a particular astronomy event, and so on. So this is a very, very good resource. You should definitely check this out. This is one of my favorite websites called Heavens Above. So they also have an Android application. And this Android application has the same features which this website is offering. Okay. And this website allows you to generate predictions of satellite passes as well as some astronomy events. So in the satellite section, you can click on any satellite and you can immediately see the predictions of the satellite passes along your area. So first you need to log in and you need to enter your latitude and longitude. Once you do that, you get the predictions for all the satellites which are mentioned here. You also get predictions for solar eclipses, you get predictions for comets. So you can learn if there is any good comet in the sky, and you can plan and observe that comet, or you can also plan an event for that particular comet. So this is a very, very good resource, heavensabove.com. They also have a mobile app called Heavens Above. Apart from that, there are some miscellaneous calendars. So this is the CSky.org, which is SEA sky.org, and they have they create these astronomy calendars for different years. So this website will give you astronomy calendars up to the year 2030. So you can very well sit and plan events up to 2030. And this website will give you the entire list of all the repetitive events which happen every year. So there will be meteor showers, there will be mention of full moon, there will be mention of visibility of planets, and all the similar events that you can plan. Similar to this website, there is also another website called inthesky.org. And this website also allows you to export all these astronomy events, and you can directly add these events in your calendar. Okay, so this is another very good tool that you can use. And this is how you can get to know about all the upcoming astronomy events, and you can plan your own event around that particular event. So this is called inthesky.org. So in the sky is very easy to remember, and you can get astronomical calendar on this particular website. Now, for the last, I also want to tell you about two very good magazines as well as websites. One is Sky and Telescope. So as I grew up, when I was a kid, school-going kid, I used to read Sky and Telescope and astronomy magazines a lot. And these magazines gave some wonderful articles about astronomy, some astronomical events, upcoming space missions. It gave some beautiful articles about how to make and use a telescope. Then also, this is basically very good guide for a beginner. And if you are very, very new to astronomy, this is a very good magazine that you can get. And you can learn about what all is going on in astronomy and space science right now, and how can you learn more about whatever is happening. So you can get these beautiful articles which are written by experts, scientists, as well as astronomers from all over the world. And this is a very, very good resource that you should definitely check out. So there is also calendar, space calendar by space.com. You can also use that one. And you can easily add these calendars onto your own calendar, is what I wanted to show. So lastly, I would like to show you the Stellarium application. So you can get it on stellarium.org. If you are interested in contributing to this application, if you are a developer, if you would like to localize this application, meaning if you would like to translate the interface of this application in your own languages, there is also provision to do that. This particular thing is known as localization, and you can very well participate in that as well. And this is a free and open source software, and it is a software which has been built by the astronomy community. And some of them who are also very good developers, and you can find and use this software on all these platforms. And this is a beautiful tool. You can also use it on the web. So even if you don't have any computer, you can just, good quality computer which can run this software smoothly, you can run it in a browser like I'm doing right now. So the interface of the browser and the application which you install on the computer is slightly different, but the features are all the same. Okay. So this will allow you to observe some beautiful phenomena, and it can help you plan your observations as well as events, whatever you are going to design. So this was the Stellarium web view. Let's end after looking at the Stellarium desktop view and move on to the next session. So this is how the Stellarium desktop looks like. And this is the current sky at Pune. And what is really cool about this application is that you can change your location and you can get to see the current sky at that location. Right now, the location is Pune, India, right? So if you are curious how the sky is looking right now in Japan, you can just enter any city in Japan. Let's take a famous city in Japan. Let's take Tokyo. So if we go to Tokyo right now, this is how the sky looks like in Tokyo, right? This is really cool. I mean, you can enter any location and you can get the current sky, how it looks, right? If you want to go to California, let's go to Davis, California. All right. So this is how the sky is looking right now in California. There is a vast difference between the sky that you see in California, in Japan, in Pune. And it is very, very interesting to control all this on the click of a button. And that is how powerful these softwares are when you want to simulate something like they simulate in case of a planetarium, right? And you can also fast forward and rewind in time. So right now I have fast forwarded, and this is how the Venus and Moon will be moving in the sky. This is the Milky Way galaxy, and July, August are the best times to view the Milky Way galaxy in the sky. And just besides the Milky Way galaxy, there is Moon, and you can just center object by pressing spacebar, and you can zoom in. So this is the Moon phase today. Okay. If you see the Moon through a telescope or a binocular, this is how the Moon will appear. Even with the naked eyes, you can very well see the half moon. Then this is planet Venus, right? Now let's zoom into Venus and see what phase do we see. Check this out. So this is how Venus will look today. And I think that this is very exciting. And if you give your students this tool, and you ask them to play with it, they are going to enjoy it a lot. And even they might come with some interesting events that they would like to arrange in school. So just after sunset, you can see Venus, Saturn, Jupiter in the sky. And you can see them with your naked eyes. And you can also see them using binoculars and telescopes. So these are some of the good tools, websites, and softwares that I wanted to show. Which you can use for planning an event. And after you execute the event, then there are so many more ways to follow. So you can produce a questionnaire. You can ask the students to present whatever they learned. You can ask them to paint something, and the painting should describe whatever they learned. You can ask them to write an essay. You can ask them to narrate a poem, and that will help them understand the topic and understand about the event more effectively. And it will be a good revision and a follow-through. And you will also get a very good feedback, whether the event was a success or was it a failure, and are there some improvements needed. And then the next events can be further adapted accordingly. So thank you for patiently listening to me. The next session will be on planning a hands-on activity. And I would like to invite Shivani as well on the dais to conduct this activity. So right now she will be taking over, and we both will be joining with you. So let me quickly start the session. I hope it's okay if we take the questions after this session.
Sure, Afella.
If there are any quick questions that you would like me to address, I would be very happy to take them. If not, then let's continue after the session. Okay. Me इधर stop.
Yes, hello everyone. Am I audible?
Yes, Shivani. Yeah.
Yes. So thank you, Atharva. It was a really great and enlightening session. We actually use all these toys while teaching kids and while taking or conducting some activities here in Ayuka. As Atharva said in his first 2 to 3 slides, that we have a really great platform at Ayuka for these science toys and space toys. So we have recently launched it on our website, that is Space Toys, and Science Toys is coming down from generations, and it is a big hit. That is what I will say, because all the schools, nearly 250 to 300 schools from near Pune and from in Maharashtra have visited Ayuka to watch and to make or to participate in workshops of science toys with us. So I'm very happy to share some of these toys and some activities with you, which you can plan actually directly on the spot while going into the classroom. Because whatever activities that Atharva just pointed out in his session, or the activities, space activities that you would like to plan out, for example, Zero Shadow Day or Eclipse, are activities for which you would have to wait for a while, like 3 months, 6 months or so. But what if you want to plan an activity or plan an event today in the class, after going to the class today itself? In the class, you want to do it in the class. So we are very happy to show you some of the activities today, which will need really very, very simple material and least materials, which you will definitely find in the class, or you can ask kids to bring it from home, and it is very easy to find at home also. So before starting, I had circulated a list of material that we are going to need today for today's activity. So can I get some teacher in the audience to give me a feedback if you have received the list of activities that we just circulated? Any teachers, any of the teachers? I would like if the teachers, at least in the meeting, would participate a bit. Otherwise, like all the teachers do in the class, I would be forced to point out to some of the names in the list. But Divya Shri, Kavita Bhatt, or anyone in the audience, just give me a feedback. Veena, just give me a feedback if you have received the list, at least if you have received the list.
We would like anyone from the audience to confirm the materials list that was sent to you all through email.
Akshata, Arun. Deepalakshmi, no one? Okay, we're getting some on the chats. No, they've written that Atharva, your session was very good.
So some of them have not received it.
Oh, they have not received it yet. Arunima has not received it yet. Okay, that's fine. I think the material that you'll just see it in the presentation is very simple. We had written down the material like a simple A4 size. Am I visible?
Yes.
Yeah, A4 size paper like this, some pencils, pen, some water bottles, like these, water bottles like these, or straws, maybe some scales. So these are all the materials easily available at home or easily available to the kids also. So I think these materials are not very difficult to find at all. And now let me just tell you a bit about the Space Toys initiative that we have started. So astronomy, what happens is when we say astronomy, kids just find it easier, or they just picture about rockets and astronauts. But as teachers and as educators like us would know that space toys or space is not just about rockets and astronauts. So basic physics, clearing the concepts of basic physics is also very important to dive into astronomy. So that is what space toys help in, or the science toys help to do, that clearing basic concepts of physics. This is a very, very nice quote that I love. When a child is taken away from toys, he or she is detached from science. I'm not saying this. This is said by Dr. Pratap Rai Chaudhary. He is an experimental physicist from TIFR. And this is what he says. And I really believe in this, because if there are some mothers in the meeting right here, they would like get this in a second, because when our child is maybe 6 months old or 1 year old, we have an habit to carry a toy in our purse, right? So if he starts crying, just hand it over to him and we are good to go for at least 15 to 20 minutes. But this habit goes off or shades away when our child goes to school in first standard or second standard. We don't carry toys anymore with us, and we also don't let them play with toys when it's study hour or when it's time to study. So we bifurcate these two things. What we say is, no, don't play with toys right now, it is time to study now. I'll give you a different time to play. So we at Ayuka believe that this can be combined. The time to play and time to study can be combined, and we can teach them through playing, and science can be taught through toys. So let's start the session, and let's go to our first activity. It is a very simple activity. It is a scaled solar system, and the material that this activity needs is also very, very simple. What we need is, we need just one A4 size paper, a pen or a pencil, just one A4 size paper and a pen or a pencil. I'll tell you in detail what you need to do and how it is very interesting or effective is what I'll just tell you in a bit. How to make, I'm just going to continue. And what you can teach is, you can teach the solar system distances and how you can relate this to the class. Like, I have this activity, but how to relate it to my textbook, how to relate it to my curriculum. This is what is very easy. 8th standard science textbook, 17th chapter, stars and the solar system. While you're teaching, if you're an 8th standard science teacher, while you're teaching the 17th chapter of your textbook, I mostly refer to the NCERT textbooks. Stars and the solar system is the chapter. While teaching this chapter, you can do this activity in the class. So what you need to do is, you just have to take a scale which every kid carries to the school, and every kid has a A4 size paper. Just tell them to measure the length of this paper. They can do it in centimeters. So any A4 size paper is roughly 29 centimeters, around 29 centimeters. So what we have here is the scaled distances of these solar systems. So Pluto is included here, but as we know, Pluto is not at all a planet anymore. So we'll start from Neptune. So as you can see here, distances from the sun, AU, that is astronomical unit. So what you have to do is just write sun at this end of the paper. If the teachers in this if the teachers in this meeting have a A4 size paper with them right now, they can start that activity with me. You can just write sun over here, as we just measured our paper, that is 29 centimeters, and the actual distance in AU is also roughly 29 AU. We are going to write Neptune over here. This activity would have been more fun if the teachers in the meeting would have interacted. And okay, they're asking about feedbacks. Okay, so you have to write Neptune here. Now what we are going to do is we are going to fold our paper into half like this. So this is 29. So what are we going to get in half? Roughly. So kids, when we do it with kids tend to directly divide it by 2 and tell the answer on the spot. So it is roughly. Anyone in the audience would like to tell me which planet is going to stay here? Here is Neptune, here is the sun. So which planet is going to be here? Neptune to ho gaya. Anyone?
Would be
What distance is this from the sun now?
20.
Anyone? Yes, somebody.
That would be 20.
Sorry?
That would be 20. Taken
20?
that distance from the sun to Pluto being 40, so the center would be 20, which roughly comes to the spot of Uranus.
No, it's 30.
No, this is 29 is what I'm saying. The length of the paper. Pluto we have discarded, Tejas, because it's not a planet anymore. Should we take Pluto? Okay, let's take Pluto. Then you will need a paper which is 39 centimeters. Okay, you'll need a paper which is 39 centimeters. Then this will be Pluto. Here will be Pluto. Here will be 20 centimeters, as you say, 19 point something, because this is 39.5. This is 19 point something, which will be Uranus. You're right. So this will be Uranus. Neptune will be somewhere in the middle here, right? Then if we fold this again in half, what will be the distance? 19 divided by 5 will be 9.5, right? This distance. So what will be the planet? It will be Saturn. So when you do this, the kids will get a really clear-cut idea what is the distance. See, sun is here. So Saturn kitne paas hai aur Pluto kitna dur hai. And now Saturn ke upar bhi Jupiter bacha hai. Jupiter, Mars, Earth, Venus, Mercury, everything should fit in this part only now. This much distance only. So if sun is here and Pluto is here, now our Saturn is here, everything between sun and the Saturn should fit in this much only. Are you getting my point? Are you getting the point or the depth or the feel of this activity? So इतना बड़ा distance है और हम सबको इतनी जगह है, अर्थ पता नहीं कहाँ आएगी. So now we are on Saturn. We folded now 9.5 divided by 2 around It will come around something around 4.5 or 5, right? So our Jupiter will fit into it. और आधा कर देते हैं. So इतने में तो Jupiter ही आ गया. So we have this only this much of area for all our planets now. Mars, Earth, Venus, Mercury, सब इतने से distance में fit होने चाहिए. और Neptune देखो कितना दूर है. We have to keep folding it into half and half and half and so on. So I just wanted to give you an idea and a simple activity to where we can show the kids or actually make them feel the distances of the solar system. Let's go to the next. Yeah, this is a very fun activity and my favorite, personal favorite. So this is a paper rocket with a launcher. And the bottle I just showed you is the launcher, and this is the only material and a paper that we require to make a rocket and a rocket launcher. I have deliberately shown a Dettol ka bottle here because due to this pandemic, every one of us will be having at least one Dettol ka empty bottle at home. So that is also good. Or any sanitizer bottle, empty sanitizer bottle can be done. So no kid can complain, I don't have an empty bottle. So bring any sanitizer or Dettol bottle and your launcher is ready. So what all you need is a plastic bottle, a stiff straw. If you don't have a stiff straw, you can use an empty pen body, empty pen body. Remove the refill and that pen body can be your empty stiff straw. You need tinted paper or simple paper, A4 size paper and some sellotape. How to make it? I'll just show you a small video where I have made this. So I'm going to cut a small strip of this A4 size paper, white paper. If it is used, it is really good. We are not wasting paper again. So please use a used paper. So that is good also. You can also use a PVC pipe like this as I've shown here instead of this stiff straw, or the pen body as I'm showing it right here. So now let's start by making the rocket. So first take the water bottle, and what we are going to do is make a small hole inside this. Just a scissor can cut a hole. We don't need something very fancy instruments to a drill machine or something. Nothing needed. Just a scissor can make a hole in the bottle cap. The hole's diameter should be as big so that the stiff straw can fit into it. Okay, so keep drilling till the stiff straw fits into it really nicely because we have to make it airtight. So air should not leak from that hole. So keep a small part of the straw below the cap and all the bigger part above the cap. Seal it with glue gun or Fevikwik so that it becomes airtight. Becoming airtight is very, very important. So this part should become airtight. And small part of the straw should be inside the bottle and the bigger should be outside the bottle. And that's it. Your rocket launcher is ready. So now let's see how to make the rocket. So as I have the small paper, I'm cutting a strip out of the paper and I'm rolling it against that same straw which you're going to use on the launcher. Same thickness we want, and making a nice paper straw out of that. So this is our complete body of our rocket. It should fit nicely or slide nicely inside your launcher straw. Or if you use a pen, then a launcher pen. Now what we're going to do is we're going to seal one top part of the rocket with sellotape like this. We are going to add a cap, but that's just for fancy, like make it look like a rocket, but it should be airtight. So we are going to add sellotape, really nicely airtight. If it is not airtight, your rocket will not be launched. Keep this in mind. The rocket should be airtight from one side. The other side should be empty. We have to put it in the launcher. But one side of the rocket should be nicely airtight. Now I'm making fins and the cap of the rocket so that this paper straw looks like a rocket. So just make 4 triangles out of the tinted paper. 3 we are going to use as fins and 1 as the top of the rocket. There is a small trick to attach these fins as they have to stay vertical. So I'm going to show you that trick. You please don't use glue gun or Fevicol. Fevicol is worst. It will not dry like for minutes and then the kids become impatient. So don't use Fevicol or any glue. Please use sellotape everywhere. So sellotape is the best option, is what I suggest. So I have made the nozzle and again sticking it with the sellotape. This is just some fancy stuff. If you don't want to do this, you can skip this part. Just the straw, paper straw sealed on one side also flies like a rocket if you put it on the launcher. But this is something which the kids love if the paper straw looks actually like the rocket. Now I'm folding this part because it is very important and sticking half sellotape on that part and leaving half out to stick on the paper straw. So carefully look at this step. I'm putting half of the sellotape horizontally on that folded part and now half I will put on the cut the excess sellotape. Yes, put this half on the rocket. So now this fin will sit like erect, nicely erect. You can do this by putting the stiff straw inside so you can stick it nicely. And I'm doing the same thing with all the 3 fins. And now let's see how our rocket looks when we launch it. So this is the rocket. Just press the bottle and your rocket is launched. So kids love this activity a lot. Launching is the best part. So just press this bottle and the pressure created because it is airtight and I'm squeezing the bottle. Now the air has lesser volume to stay in. So it has created pressure. And so that pressure is used to launch the rocket. Now what all can you teach? This is very good for geography teachers also, not only science teachers, but geography also has a part where you can teach where and why rockets are used. And it is in the 7th standard geography textbook, 3rd chapter. Chapter's name is Tides. Okay. I also have some screenshots. Yeah, see, I also have some screenshots of the textbooks. Large rockets are used to go into the space away from Earth. Which force do they act against? So geography teachers can also use this toy to teach in the class. So I have this screenshot of the textbook directly. Let's go to the 3rd toy. It is a satellite model and it is the easiest toy that you can make. So as you can see, You have one ball here, the other ball here. You can use a sharpener, a rubber, stones, anything that is a small part which is lighter in weight and the other object which is heavier in weight. And you just need to tie these things. You tie one end of the string to one lighter object, pass it through again a straw or a pen, and tie the other object. And when you spin it, you can show them that this is the earth and how the moon or the satellite rotates around it. I have a film, but as we don't have a lot of time, I'm not going to show you that film. If you want, you can message us in the chats and we'll send you the links to these films. So what can you teach is centripetal or centrifugal force. Again, science teachers, 10th standard syllabus. First chapter, gravitation, has similar, see, you have all these things which you need to teach, where you can use such nice toys in the class. You can ask one kid to bring a bigger ball, one kid to bring a smaller ball, some kid can bring a thread, someone can bring a straw or a PVC pipe, and in just 5 or 2 to 5 minutes, you can make this toy in the class. And this is my personal favorite. This toy is my personal favorite, and it's the gravity drop. So this needs just one bottle and one some pointed object, a needle or something. And this is my personal favorite. You need to do nothing, just make a small hole in the water bottle and fill in water, and then you will be amazed to see this results. And you also need a smartphone or a mobile phone to capture slow motion videos. This I will like to show the so the water is falling now. What will happen when I drop the bottle? You can see instantaneously the water from the hole of the bottle has stopped coming out of the bottle. When I drop the bottle, instantly there is water inside the bottle. As you can see, water is coming out. There is water left, but the water stops instantaneously when you leave the bottle, and it is coming down. This is very interesting. You can teach that gravity acts same on all the objects and why the water is not coming out of the bottle when we drop it. You can also teach them how universe or nature takes the easiest path or conserves energy from this. And you can teach gravitation for 9th standard students also. I have one paragraph where you can actually teach this paragraph with this toy. It is again a screenshot from textbooks directly. And this is our last activity, and it is a very fun activity. Would you like to take this? Yeah. Yeah? Okay. So this is a very fun activity, and this is also very favorite amongst kids, and it is a paper folding activity.
Okay, Shivani, before we proceed further, I request all the teachers to take part in this paper folding activity because it's very simple. I would like you all to switch on your cameras and take a sheet of paper, please.
Yeah, just one paper, that is all you need. You will yes, Arun, we will share. It is easier if you send us mail. Our email ID is scipop@gmail.com. If you would want my personal email ID, it is shivani@ayuka.in. Atharva? Yeah, we'll display our email IDs afterwards where you can send us mail and we can send you all the links to these videos. Is that fine, Arun?
You can unmute and say yes.
You can unmute and say yes. That's okay. That's okay. Fine. So this is a paper that we're going to need. Just one paper, and we're going to start folding this paper. 1, 2.
We are folding it in halves.
We are folding it in halves. Okay. So this is the whole paper. I folded it in half. I again folded it in half, I again folded it in half. So what do you think, how many times can we fold this paper? Can anyone tell?
Not more than 7 times is what I've heard. So
Not more than 7 times, okay. And can you guess what will be the thickness of this paper? A small printing paper, a small A4 printing paper. You can Google it also, that's not a problem. So what would be the thickness of this paper according to you?
70 GSM.
Sorry?
Around 70 GSM.
Okay, so can you tell it in centimeters so that it is easier to calculate the further calculations?
Maybe around 0.1 cm.
Okay.
No,
So
0.1 mm. 0.1 mm.
0.1.
0.1. Okay, any more guesses? So 0.1 centimeter is very thick, is what I'll say. This paper is very thin. So you can Google it. It is around, I'm talking about A4 size printing paper. It is around 0.001 centimeter.
Or 1 mm.
Or 1 mm. Okay. So it is that thin that we are talking about, that thin paper. So I would like to ask you 2 questions. How many times do you think you can fold? That is 1. And another thing we need to consider is what will happen to the thickness of the paper once we start folding it. Anyone? So as they just said, he said we cannot fold this paper more than 7 times. Okay, considered. And the second question is what will happen to the thickness of the paper? Please participate. This is going to be really interesting and fun when we reach the end. So what will happen to the thickness of the paper? So the thickness of this paper is, yes?
It keeps doubling.
Okay, right. So 0.001 centimeter. Now, what is the thickness of this paper when I fold it in half?
0.002.
What will happen when I fold it in half again? Not 0.003.
4. It would be 4.00.
Yes. So if you keep a track, you will see that it will go on like 0.004 for 2 folds, 0.008 for 3 folds, 0.016 for the 4th fold. Right? So do you realize that every fold is giving us double thickness? So the thickness is becoming double. So now let's start calculating and see what will happen when we fold the paper 10 times. Hypothetically, what will happen when we fold it 10 times? What will be the thickness?
2 power
What?
10.
Sorry, 2 to the power?
10.
10 into?
0.001.
Thickness of the paper, right? So what is 2 to the power 10? 1024. It is 1024. And when we multiply it with the thickness of paper, that is 0.001, what will be the thickness of 10 folds? It will be 1.024, right? Now, imagine what will happen if we fold it 17 times. Now, I'll give you a small trailer. If I will fold the paper 45 times, if I can fold the paper 45 times, I can reach the moon. Is this interesting? Is any one of you finding this interesting? If I see this simple paper, if I am able to fold this for 45 times and climb it, I can reach the moon. I find this very interesting and very fascinating. I don't know if any one of you is finding this very interesting. I'll tell you the calculations. If we fold it 17 times, the thickness is going to be 131.072. If we fold this 25 times, the thickness is going to be 33,050 554 centimeters. And if we go 40 times, what will happen? It is going to be 10,000 kilometers. And I think that is approximately the height of a GPS satellite that orbits. Yes, if I'm able to fold this paper for 40 times, I'm going to reach a height of 10,000 kilometers, and there's the GPS satellite that's orbiting. And I personally find it like, it blows my mind. It really is fascinating for me. What will happen if I fold this paper 45 times? So as a teacher, you don't tell this at first. You just tell the kids to calculate. Just keep on calculating. हाँ, अब क्या होगा? 17 times fold करोगे तो क्या होगा? 30 times fold करोगे तो क्या होगा? Now calculate it for 45. The kids are just calculating the numbers, and they'll actually calculate it accurately. 45 times hoga to kya hoga? They'll say, ma'am, it will be like 3,84,400 kilometers approximately. And then you like tell them that now you have reached the moon. Your folding paper has reached the moon, and fold it just one more time and you'll be back to the earth from the moon, because it's doubling the distance, right? So this is very, very fascinating for me. And I just received, Atharva actually got this idea of this photograph. And I think, can you elaborate?
So this photo was taken by Bill Gates. So this photo was taken very, very long back. The time when we were using CDs, and CDs were new in the market. And what he's trying to show you is, you can see the two stacks of papers on which he's sitting, right? So all the information that has been written on these stacks of papers is present inside that one compact disc, which he's holding in his hand. And that is how you can, store all this information in a very small space. And this is what he's trying to tell you. Now imagine this entire paper stack. Now we just took an idea of a small experiment where we took a A4 size paper of 1 millimeter thickness, right? And if you fold it 7 times, if you fold it once, the thickness becomes 2 mm. If you fold it 3 times, the thickness becomes 4 mm. And if you keep on doing this for 10 times, it will become 1024 mm. So which will be around 1.2 centimeter, right? Now, if you keep on calculating the thickness of more and more folds, you are going to keep on adding these thicknesses. So somebody is asking how come in the comments. So we are simply adding the thicknesses of each and every fold, right? And if you keep on calculating the numbers with the help of a calculator or even on paper, you will get bigger and bigger numbers. And if you do this fold 45 times, of course, you cannot practically do the fold 45 times. You can only do it 7 times because the paper does not allow you to fold more than that. Okay, this can be a very good homework. You can explain why can you not fold more than 7 times. So there is a very good explanation to that, and this can be a good homework for you. Since you all are not at all responding to this, this can be a very good homework for you when you leave the session and find out the answer why you cannot fold more than 7 times. So this is a very good example or a very good illustration, you can say, where the same paper and the stacks of the very same paper, and this stack is almost as big as a pine tree. This could be almost 30 to 40 feet. And all that information is now, we are able to store all that information in a very small compact disk. And at the time when this photo was taken, this compact disk was a brand new technology. And people were not eager to use it. They were comfortable in using papers. But nowadays, we are also considering this compact disk to be outdated, and even more and more memory devices are being developed. But this is to give you an idea. So the very same paper, which was folded 7 times, gave us a small thickness. Now imagine the distance that folding all these papers will cover. And you can probably scale even larger distances. So the intent of this activity is to give a sense of scale. A very, very small object, if put together on top of another, will give you a very, very large distance, right? So this is to give you a sense of scale. So the moon is at 1 light second. So when you tell students that when you fold the paper 44 times, you will get a distance from the earth to the moon. You can also tell them the same information during the time, that light will require only 1 second to cover this distance. And when you do this activity and tell this information, the students are going to remember it for a very, very long time.
Yes.
And that is why we are doing all of this. So we hope that you all will not forget it for at least a few days now. And you all will do these activities and probably ask your students to do them as well. So thank you for patiently listening to us. And if you have any questions, please unmute yourselves and talk to us. And
we'll be happy to answer.
We will be happy to answer them. I see no questions on YouTube, but whoever is there in Zoom, if you have anything you would like to discuss, if you would like to tell us some event ideas from the previous session, we are here to listen. Go ahead, unmute yourselves and talk to us.
Okay, we have Dr. Mausami thanking for this session. Ma'am, can you please come on the screen and share your experience with us? That would be great.
Thank you very much, sir. This is Mausham Bhanti from Odisha. I got very interested sessions through the video, and I should explain to my kids also. Basically, I am a lecturer in a degree college, but I put very interesting sessions during the main thing is that thickness give you we can when we fold the paper we can reach to moon. That is a very interesting I know it is practically not to be happen clearly, but thank you very much for the beautiful session by the teachers. Thank you very much.
Thank
you for joining.
Thank you so much, ma'am. If we have any other people in the audience out there who want to talk about the session, please feel free to come up. I see most of you are befuddled, like looking at this particular activity as to how staking up papers will take you all the way up to moon. I mean, yeah, it is hypothetically, let me phrase it. Okay. So do we have anyone else from the audience who would like to share their experience or ask a question to the speakers?
You can also share a suggestion. So if you think something more should be included in a similar session that we will do, probably not today, but maybe sometime later, we will be happy to incorporate that.
Yes, someone, Nayan sir is saying do live. Please repeat pen rocket.
Okay, so the model. So this is the model actually. This is a paper which has been rolled and we have used the straw while rolling that paper, and the straw is sealed from one end, right? And once this paper straw is inserted on a normal straw, the straw is affixed to the bottom, right? So the rocket can fly like this. So this is a very simple experiment. It does not require any fancy equipment, and you can easily teach kids how propulsion. Basically, you can teach them about air pressure. You can teach how rockets fly. What force are they trying to overcome? The most important force is the force of gravity. But in a way, rockets also use gravity to keep flying. So we only overcome gravity when we want to put the rocket outside the Earth's atmosphere. But if we want a part of the rocket to revolve around the Earth, we are not going to use any fuel. We are just going to use the gravity to make the rocket keep on rotating around the Earth.
Okay, there is one more question. Straw is closed from what? This straw is not at all closed. It is open from this end and this end also. The paper straw that we just made is closed from this end. It should be airtight. I'll show you. I'll open this. It should be airtight and closed with a sellotape or a paper, whatever is comfortable, from one end, and it is open from the other end. Any more questions?
Good evening, sir and ma'am.
Yes, good evening, ma'am.
Ma'am, the session was very good. Then you have shown how to make the rocket and also other, no? Can you share the link or any video of that one?
Yes. So what we can do is we can share everything with Tejas, and he will make sure everything reaches everybody.
Yes.
Okay. I mean, is there any mail ID to send?
So let us quickly share that page.
And also, ma'am, is there any sessions for the high school students?
Yes.
Yes, we do have sessions for high school students. So you can just
let me quickly share.
Yeah. You can write it down. Yeah, you can just email us on scipop@gmail.com, or you can call us on 02025604602, and you can book a session with us. You can email and book a session with us. Whatever standards, how many students do you have? You can write everything in that mail, and then we can schedule a session for you accordingly.
Okay, ma'am. Also, can you have any courses for the students or certificate courses, because they will not have any idea how to go for as you are working. What is a path we have to follow after the 10th or PU?
Yes, we don't have a course or anything, but we have a poster where we have explained everything. After 10 standard, what you can take, what you can do. After 12 standard, what can be done. We can share that like poster with Tejas too.
Okay. No, what I'm asking is, see, as usual, we know that after PU or after 10th, we can go for BSc or like that. But if you if we want to go for astronomy or any other space research organizations, what we have to do, we don't have the idea. And also many students don't have the idea how to go or how to face, what exams we have to face, and where is the place we have to go. That's why, ma'am.
The poster I'm talking about is exactly the poster just for astronomy only. Okay. So what would you need to do?
Just a second. I will share that screen right now.
So yeah.
So Shivani can talk in the background. So this is the website by JVP. On this, there is a tab called Astro World. Okay. And on this Astro World tab, you can find, just a second.
The link is shared in the chat, so you can copy paste.
You can find all universities and institutes in India that provide any kind of education in astronomy or astrophysics. Okay, you can just zoom in, you can click on the map location. There is a list of amateur astronomy clubs in your cities, closer to your cities. There is a list of observatories. There is a list of institutes and also planetariums. Okay, so if I zoom into Pune, if I click over here, there is JVP, then there is Ayuka. So you can see the home icon here. So there is the institute called Ayuka in Pune. So this map will give you a list of all universities and institutes that offer astrophysics. If you click on this link over here, a careers poster will open. Okay. Now what you asked, what the students like to know is, so students can opt any of these fields. One can opt science or engineering. And after that, along with these certifications or degrees, they will need to develop these skill sets on their own. Okay. And most of these skill sets are already developed, ideally. They are already developed as a part of your coursework. Okay. If you are bad at your coursework, you will have to develop these skill sets to be comfortable to do research in astronomy. Okay. And if you enter the field of astronomy, these are the following areas. I hope you can see the screen. I'm assuming that the screen is visible. So these are the following areas, and these are only some of the areas that we have mentioned. These are not all. And you can easily, identify your interest, and you can start working on any of these fields. So these are astronomy related career positions. Some of them are administrative positions. Even if you are belonging to some other profession, you can still work on astronomy projects. Let's say if you are a lawyer, you can still work with a mega science project like LIGO. If you are good at administration, you can work in administrative tasks related to science projects and astronomy projects. And all the people, even astrobiologists or geologists. So most of the people working on a space mission like Mars mission or Mars Science Laboratory are not astronomers. They are geologists. So we are sending a robot on Mars. And what is that robot doing? That robot is collecting soil samples. So who do you need to understand and study about soil samples? You need a geologist, right? So most of the people working on the Mars Science Laboratory in JPL, which is Astronomy Institute, are geologists. Most of the people who are working on missions related to comets and asteroids are biology scientists. So they are not experts in engineering, they are not experts in astronomy, but they have expertise in biology. And you need people from all disciplines to work in astronomy. Okay. So no matter which discipline you belong to, you can always be a part of astronomy or astrophysics. And these are the different ways which you can follow. These are the paths that you can follow. If you are a school student, you can follow these points. If you are a college student, you can follow these points. These are the free resources that you can use to appear for these exams. Okay. So for a school level student, using these resources, you can appear for these exams. And after these exams, you can enroll for a course related to astronomy and astrophysics. If you are a college student, undergraduate and postgraduate, you can use these resources and you can appear for these exams. Okay. And these blue colored are basically the direct links. So if I click here, the exam page will open. And if I clear GATE, I can directly appear for PhD after my engineering or after my MSc. If I clear GRE, I can appear for any institute entrance. Basically, if I score well in GRE, I can directly enroll for a master's course in India and even abroad. So these are the different exams that allow you to get a chance to work in an astronomy institute. And these are all the resources. Most of them are open source. Okay. Actually, all the resources in this poster are free. So, and because they are free, they are in the poster, is what. And this is a very detailed poster. You can take some time and refer this thoroughly. So this poster is one of the resources. Then on this website, which is shared in the chat, you can find a list of institutes which are in India. Okay. In astronomy and astrophysics. So this is the list of institutes which are abroad. Then there are these useful links. Some of them are astronomical magazines. You can read which link is what. Then there are some useful downloads. There are some science toy kits, spacecraft kits, and some models that students can do. And this website includes resources only related to astronomy. Right. Then this is the list of amateur astronomy clubs in India. So you have the state, the name of the astronomy club, and the address. And if there is, if it is provided, there is also a direct phone number. And if the astronomy club has a website, the website hyperlink is also given. So this is a very good resource. If you stay in Kalyan in Mumbai, there is an astronomy club. If you stay in Chembur, there is an astronomy club. Likewise. So this is a very good resource for finding out about astronomy and astrophysics specialization institutes. And also this is an excellent resource by Ayuka, where you get information about all the exams that students can give. This poster also has information about different scholarships and fellowships, which will allow the students to learn with the help of these grants. And when you do PhD in India, you by default get scholarship from the government. Okay. And you get a stipend every month. So these are the different exams and the resources. Please take a look at them and do share it with your students. And even if one of you would like to work in some astronomy institute in any capacity, it is never too late. So you can find out some work for yourself to do. Then there are so many different citizen science projects. And tomorrow's session, Dr. Priya Hassan will talk a little bit more about those as well. So come back tomorrow and also listen what she has to say. And she will also be a very good resource person for elaborating more on this very question of yours. So thank you for listening. If there are any more questions, please go ahead.
Thank you so much, Atharva and Shivani. And yes, as Atharva pointed out, we have another session tomorrow coming up on clear skies and Bright Stars by Dr. Priyasha Hassan. So please do join us tomorrow at 5 o'clock, and we'll be going ahead with the same discussion. And also there is another session planned on 14, wherein there will be elaborate discussions from 6 to 6:30 upon various career opportunities that you can guide your students with. It's not just with just respect to astronomy or space. We'll be in general guiding you all as to how you can take them to international Olympiad or promoting them in STEAM, science, technology, engineering, arts, and mathematics. So we'll be talking in this in detail regarding all these aspects on the outreach program session planned on 14. And also we have a competition planned for all the teachers on 14, which will be disclosed then. So please make sure that you get tuned in on 14. And also do check out Ayuka's page. There's a lot of information content related to astronomy and astrophysics that's available there, and also Jyotirvidya Pratishtanam. So, and also do check out SSERD's page. That there are a lot of videos wherein speakers have talked about the various exams and opportunities that are currently available in the sector of space science. So do check out those videos as well. So with that, we'll be wrapping up today's session. Thank you all for joining in. Please tune back tomorrow at 5 o'clock to join us for a session on clear skies and bright stars. So this is Stages signing off. Thank you, Atharva. Thank you, Shivani. See you all.